Hi all, I am Aishwarya presenting you the topic stack. In this presentation, we will be discussing about stack definition, representation of stack that are array representation and linked list representation, operations on a stack and applications of stack. A stack is a linear data structure and very useful in various applications of computer science. To understand the concept, let us consider an example that is a plates of a tray. Suppose a chef placed the dishes on a tray one above the other and the waiter served the dishes to the customer in the opposite order. The chef placed them, that is, the dishes at the top, which was placed last by the chef, is served first. By here itself, we can understand that a stack is something which follows the last in first out strategy. So it is termed as LIFO. Definition: a stack is an ordered collection of homogeneous data elements where insertion and deletion operations take place at one end only. It is homogeneous because all the elements of the stack are same data type and insertion and deletion operation in the stack take place only at one end. That is, insertion and deletion operation in stack take place at the top of the stack. Here we can see a schematic diagram of a stack. If we are if we are inserting any element into the stack, that means a push operation, and if we are deleting an element from the stack, that is a pop operation. All are performed at one end, that is at the top of the stack. As we stated earlier that the insertion operation is termed as push and the deletion operation is termed as pop. That is, the insertion and deletion operations in case of stack are specially termed as push and pop respectively. And uh, the position where we are performing the push and pop are termed as top of the stack, and we can say that the elements that we are inserting or deleting is termed as item. In before In the diagram of a stack itself, we can see that many elements that are item 1, item 2, those are the elements of the stack, and the maximum number of elements the stack can accommodate is called the size. Representation of stack. A stack may be represented in the memory in various ways. There are two main ways. First one is using one-dimensional array and second one is using single linked list. Let us have a detailed look on these two representation in following slides. First one, array representation of stack. First, we have to allocate a memory block of sufficient size to accommodate full capacity of stack. It means first we have to accommodate size of the stack. Starting from the first location of memory block, the items of the stack can be stored in sequential fashion. It means that the elements, the items of the stack in array are placed in a one by one in consecutive location, memory location. That is, if we are placing at a location L at element item 1, then the item 2 in L plus 1. we can see here the array representation of stack in figure A, and the item I denotes, that is the item I denotes the ith item in the stack, and the lower L. In here we can see L, the L index L, L plus 1, L plus 2. Here the L is the lower bound and U is the upper bound, and L have value usually have value 1, and you have usually size. And we can see here top, and top is the pointer to point top of the stack, the position upon which it is filled with the items of the stack. And we can state here two condition, that is if a stack is empty, and if top less than or equal to 1, that is if there is no element in the stack, and if it is full, and the stack will be full when top greater than or equal to 0. As we know that the array representation is easier, uh, but it allows the representation only fixed sized stack. Many of the case the size may be varied during the program execution. So a solution to this problem is to represent a stack using linked list. A single linked list structure is sufficient to represent any stack, and here in the list data field is for item and link field is to point to the next item, and the first node on the list is the current item, that is the item in the top of the stack, and the last node in the list is containing the bottommost item. Here the figure B represents the linked list representation of the stack, and here the current node, that is the node followed by the stack head, it is the top, contains the first element, topmost element item of the stack, and the last node that is last node item 1 contains the bottommost item, and it's the bottommost item, the last node of the linked list, the pointer field is null. And if you are performing any insertion, that is push operation, it is in the top, and if you are also performing pop operation, it is also in the top of the linked list, that is followed by the stack header. Next we can see the operations on a stack. The basic operation required to manipulate a stack are: first one, push, means to insert an item into the stack. Second one, pop, to remove an item from the stack. Here we can see an algorithm of push operation. Algorithm push of stack, top, max stk, item. Here in the first step, that is if top equal to max stk, we are checking the top is equal to max stk, that is checking top is equal to the upper bound. If it is true, then write or print overflow and return. If it is not true, or that is top is not equal to max stk, then it can have space, because it is the stack have space. So perform the push operation by followed by the step 2 procedures, that is in step 2 the top is incremented by 1, that is set top equal to top plus 1, and in third step we are inserting the element or item to the topmost of the stack, that is set stack of top equal to item, and in step 4 return. That is, it is a algorithm for push operation. That is, in step 1, if top equal to max stk, then write overflow return. Step 2, set top equal to top plus 1. Step 3, set stack of top equal to item. Step 4, return. Pop operation, that is algorithm for pop operation. Algorithm pop of stack comma top comma item. Here in step 1 we are checking if top equal to 0. That is, we are checking that top is pointing to the lower bound if there is element in the stack or not. If it is true, that is the condition is true, if top equal to 0, then print or write underflow and return. Else in step 2 we are moving to the step 2, that is item equal to stack of top, that is assigning the top element to item, and we are decrementing the top pointer by set top equal to top minus 1 and then return. Here it is the algorithm, which means the step 1, if top equal to 0, then write underflow return. Step 2, set item equal to stack of top. Step 3, set top equal to top minus 1. Step 4, return. As we stated earlier that a stack is a linear data structure and it is very useful in various applications of computer science. Let us see some of them application. First one is evaluation of arithmetic expression. It can be evaluation of postfix expression or etc. Next is expression conversion. That is, the stack can be used for expression conversion. For examples, conversion of infix to postfix expression. Second, conversion of infix to prefix expression. Third, conversion of prefix to infix expression. And fourth, conversion of prefix to postfix expression, and so on. And we can conclude our topic that we have discussed the first definition of stack, that is, a stack is an ordered collection of homogeneous data elements where insertion and deletion operation take place at one end only. And we discussed representation of stack, that is, a stack may be represented in memory in various ways. They are using, first one using the one dimensional array and second one using a single linked list. And we discussed two operations of stack, that is the basic operation required to manipulate a stack are push and pop, and we discussed the algorithm also for this push and pop, and we list some applications of stack also. Thank you.